Nice guys check twice, accounting for no signal processing and the capacity coefficient. In attention and decision-making research, we often ask questions about the relative cost of processing stimuli in isolation, for example, stimulus A and stimulus B, relative to processing these stimuli together. One of the tools from systems factorial technology, known as the capacity coefficient, formalizes this relationship and provides two measures of workload, the C or T, when processing may self-terminate after detecting any stimulus in a minimum time search, and the C and T, when both stimuli must be exhaustively processed in a maximum time search. Both of these measures assume that participant response times reflect stimulus processing and ignore processing times that may arise from the target absent channel. In this talk, I will show why this assumption may be incorrect and how we can solve this issue with a new task and analysis tool. To explain all this, we'll show data from Eidels 2015. In their task, participants were asked to detect the presence of one or two dots of light presented at either a high or a low salience, and participants completed a maximum time and task and a minimum time or task. Processing architectures, as measured by the survivor interaction contrast, show double target trials were processed in parallel under both search rules. However, capacity coefficients differed. In the AND task, participants were facilitated by the additional double target dot stimulus, showing supercapacity, and a CT greater than 1. In the OR task, participants were slowed by the additional double target dot stimulus, showing limited capacity and the CT less than 1. Here we have the same stimuli, the same participants, and essentially the same tasks, but wildly different measures of workload capacity. To untangle this mystery, we now consider the single target processing times. In the OR task, participants can self-terminate their search after detecting a single dot of light. Here, processing was faster for the higher salience white dot than the lower salience gray dot, giving us the clear separation in the survivor functions displayed on the left. In the AND task, where a yes response can only be made if both dots of light are present, participants can efficiently self-terminate their search by looking for the absence of a target. This bypasses any processing of the stimulus salience, resulting in uniform processing times seen in the survivor functions on the left. With the AND capacity coefficient informed by both single and double target processing times, this poses an issue to its interpretation. To fix this problem, we took the typical AND task, where participants responded yes if both stimuli were present and no otherwise, and mapped it to a full identification task. Here, a separate key was mapped to each stimulus, and both keys were pressed simultaneously in the event of a double target trial. A separate key was mapped for no target trials. This new design allows us to create a new measure of workload capacity, the CID. Unlike the typical C and T, response times for all trials in the CID equation must be processed exhaustively. As such, processing times for the absent channel can be factored out by including the non-target trials in the denominator of the equation. Using this new identification task and new measure of workload capacity, the CID, we collected data from the same stimuli as Eidels 2015. We begin by showing the survivor interaction contrast on the left. You can see that processing architectures were parallel minimum time for the OR task and parallel maximum time for both the AND and the identification task. Turning now to workload capacity, and the CID presented here in green closely aligns with the results from the OR task presented in blue, and no longer reflects the inflated workload capacity of the AND task displayed in red. To summarize, our full identification task and new measure of capacity, the CID, now solves an issue that has plagued SFT studies for years by accounting for no signal processing times that were otherwise overlooked in the typical AND task, affording a comparable measure of workload capacity to the OR task. If you'd like to know more about this work, please see our psych review paper authored by Zachary Howard and entitled A Show About Nothing, No Signal Processes in Systems Factorial Technology.